Hey everyone, welcome back to my channel where I take you through high school math and physics problems. Today we're going to be going over rational expressions, which is a part of grade 10 math. This video is meant to be an extension of the video I did previously on factoring because rational expressions are a practical application of all the factoring tools we've learned previously. They can be used to make your life a whole lot easier and simplify kind of complicated expressions. So if you need a refresher on some of those concepts, check out that last video I did on factoring. And as always, if you guys like this content, please consider liking this video and subscribing to the YouTube channel so I can help grow the channel to reach more students. Okay, so for question number 1, we're going to have x squared minus 8x plus 7 divided by x squared minus 10x plus 21. So this is all a rational expression is. We have a polynomial on top. So polynomial on top, or I guess in this case, since it's 3 terms, 1, 2, and 3, trinomial on top, and a trinomial on the bottom. So the question might ask, it'll probably say, simplify. So if we look at this, we can see that this is both the top, the numerator, and the denominator are both a trinomial where a is equal to 1. And this is the a right here. I guess the a would be right there. So to factor this, or I guess simplify this expression, what we do is we do it in chunks. We look at the numerator term first, and then we'll look at the denominator. So to factor the numerator, I'll write it in yellow, we're going to write out all the factors of 1 times 7, and that's this 1 times this 7 right here. So if we get that, that's going to be 7, and we're going to get, okay, well we'll have 1 and 7, and 7 and 1. So we can write it in different orders, but that's all the factors of 7. So what we need is, we need these factors to sum to this middle term, which is negative 8x. So if we took negative 1, and then we added it to negative 7, that would give us negative 8, which is our middle number. So by that logic, we now have a factored form of this above expression because we had our a term, which was this 1 here, and our c term, which was this 7, and the sum of them, the sum of the factors of that term, ended up equaling this middle term, which is 8x. So we have the top expression could be written in this factored form as x minus 1 multiplied by x minus 7. And so that's now the factored form of the numerator. For the denominator, we look at it, and again, we kind of follow a similar process. We're going to do 1 multiplied by 21. So 1 times 21, and that's going to give us 21. And we can list all the factors of 21. So we can do 1 and 21, and we can also do 3 and 7. And we need some of these factors to sum to this negative 10x here. So if we had negative 3 and negative 7, so negative 3 plus negative 7, this would just be equivalent to negative 3 minus 7. That's going to equal negative 10, which is our value. So we know that negative 3 and negative 7 are the numbers we need. So the denominator can be written as x minus 3 multiplied by x minus 7. And here you can see that this whole term and this whole term are the exact same. So it's basically equivalent to saying 1 over 1. So we can just cancel that out. And then we can write the expression as x minus 1, I'll write it over here as the final product, x minus 1 divided by x minus 3. So that would be the simplified rational expression using our factoring tools. So we're going to go on to question number 2. And these are going to get a little bit harder each time, but the same kind of tools of factoring are going to be used in each of the questions. The next one is 8x plus 56 divided by x squared plus 8x plus 12. And then this is all multiplied by x squared plus 14x plus 45. And that is divided by x squared plus 12x plus 35. So again, this looks a little bit more aggressive than the last problem, but we're going to just take it one step at a time and look at the numerator of this one, the denominator of this side, and then equivalently the numerator here, and in purple, the denominator here. So we start with the numerator of this one right here, this green term. If we factor out a 8, we know that there's an 8x, or we're using kind of greatest common factoring. So there's an 8x, and 7 times 56, 7 times 8 is 56. So we can factor out an 8, which is going to be x plus 7. So that's this term factored out. And that's kind of all we can do for that numerator. Next, we're going to look at the blue term. And again, we have a trinomial where a is equal to 1. So we need numbers that their product is 12 and their sum is 8. So we can write x plus, well, what are the factors of 12? It's 1 and 12, 2 and 6. 2 and 6 right there. There's also 3 and 4. But 2 and 6 work because 2 plus 6 is going to equal 8. And that's what we're looking for here. So we can write that as x plus 6. Now we can do times, and we can deal with this orange term here. And similarly, we have x plus some number and x plus another number. So we can look at this as, okay, what two numbers what two numbers give us 45, or 1 times 45, and their sum equals to 14. Well, if we go through all the factors of 45, we'd find that 9 and 5 are a factor of 45, and 9 plus 5 give us 14. So we can write x plus 9 and x plus 5. So now we've factored this top term. And finally, we can use purple for the bottom term. We can write x plus some number times x plus another number. And here, we're going to look at this one, and we're going to say, okay, well, what factors of 35 have a sum to equal 12? So if we did 7 and 5, 7 plus 5 is going to give us 12, and 7 times 5 is going to give us 35. So that's where we can write x plus 7 and x plus 5. And now, similar to the last expression, where we crossed out the numerator term and the denominator term, we're going to see if there's anything else we can cancel here. So another way of writing this entire expression with this multiplication here, this is just multiplying fractions. So we can write 8x plus 7, and when you multiply fractions, you multiply the numerator and then you multiply the denominators together. So we can have this numerator here multiplied by this numerator. That's going to be x plus 9 multiplied by x plus 5. I'm going to finish that, and then the denominators are the same. So it's going to be x plus 2 times x plus 6 multiplied by x plus 7 and x plus 5. And now we can see if we can simplify or cancel out some of these terms. So we have a common term x plus 5 in the numerator and denominator, so that can be canceled. We also have a common x plus 7 in the numerator and the denominator, so that can also be canceled. And then, see if there's anything else. Doesn't look like it, so we can finish by writing 8 times x plus 9 divided by x plus 2 times x plus 6 is our simplified rational expression. And that was question number 2. So we can now go into question number 3. And again, these are going to get progressively harder, but it's the same concept each time. So x squared minus 2x minus 8 divided by 2x squared minus 8x minus 24. And then this time it's divided by x squared minus 9x plus 20 divided by x squared minus 11x plus 30. So we're going to do the exact same approach. We're going to look at this numerator here, factor it, and we're going to look at the denominator here and factor that version. Look at the numerator over here, factor this, and look at the denominator, I'll do it in green, on this side, and factor that. So for the orange term, we have a trinomial, so we have x, and it's going to be minus, and then x plus. And the reason I did that was because this value here, this value right here is a negative, and this is also a negative. So if the 8 was positive, it would be a negative number times a negative number, right, which would give us a positive number. But because there's this first negative here and the second negative, I know that one of the numbers is positive and one of the numbers is going to be negative. So the factors of negative 8 would be negative 4 and 2, and that would be the one that would actually work because there's also 8 and 1 and all that kind of stuff. But negative 4 plus 2 is going to give us negative 2. So we can write x minus 4 and x plus 2. So that's the numerator factored. And I'll do this, and then I'll do it in blue. So now we have a trinomial of where a is equal to, or is not equal to 1. So a does not equal 1. But there seems to be a common term, since these are all even numbers. It's 2x squared, this 8x, and this 24. They're all even numbers. So we can actually take out a 2 from each of those. So we can write 2 times x squared minus 4x minus 12. And we'll leave that and we'll go to the other side. If we're dividing fractions, you might have heard your teacher say multiplying by their reciprocal. So when you're dividing fractions, all we're going to do is multiply and switch these two terms. So on top we're going to have, instead of x squared minus 9x plus 20, we're going to have this green term. So we're going to have x squared minus 11x plus 30, and that's going to be divided by x squared minus 9x plus 20. I should do it in yellow. X squared minus 9x plus 20. Now that everything kind of looks similar to the last question, we can go about our factoring. So this top term is going to stay the same. We've already factored it. And this bottom term here, we can now factor it as a normal trinomial where a is equal to 1. So it's going to be x minus times x plus, and okay, so what are the factors of negative 12 that sum to negative 4? So if we look at that, there's 6 and 2, and that's kind of the one that works. So if we have negative 6 and positive 2, negative 6 plus 2 is going to give us negative 4. And also, negative 6 times positive 2 is going to give us negative 12. So then that would be the denominator factored. Looking at this green term, we have x minus, and then again, x minus, because a negative times a negative is going to give us this positive. We have to account for this negative here. So if we look at the factors of 30, it'd be 1 and 30, 3 and 10. 6 and 5 is also another one. And if we do negative 6 minus 5, that's going to give us negative 11. So we know that that works. And also, obviously, negative 6 times negative 5 is positive 30. So we can now look at the yellow term. And this is multiplied still. So those yellow terms are going to be x minus something times x minus something. So 1 and 20 is a factor, or factors of 20. 2 and 10, and then we also have 4 and 5. So if we have x minus 4 and x minus 5. So negative 4 plus negative 5 is going to be negative 9, and negative 4 times negative 5 is going to give us positive 20. So now we've factored all of our, numerators and denominators, and now we can simplify to see which ones cancel out. So we can see that this x minus 4 is in the denominator, and there's an x minus 4 in the numerator. So we can cancel that out. We also see that there's a x minus 6 in the numerator on this side, and an x minus 6 in the denominator over there. So we can cancel that term. And just looking at this side of the equation, there's an x minus 5 on the numerator and an x minus 5 in the denominator. So we can cancel that out. And finally, we have a x plus 2 on this side and an x plus 2 on this side. So this all cancels out, and these are all just ended up being like, when I say cancel out, it's just really, since it's the same term, it's like saying 1 divided by 1 or 2 divided by 2, which is going to be 1. So what we're going to be left with is literally just this 2 right here, but it's in the denominator. So it's going to turn into 1/2. And that would be the simplified expression of this rational expression. From starting with this entire you kind of mess up here, we end up getting a value that's equal to 1/2. It's a lot more simple than we realized. Okay, the next question is going to be involved, or is going to be using addition and not multiplication of fractions. 10, 3x plus 8 cubed plus x divided by 3x plus 8 squared. So multiplying and dividing, which is really just multiplying by the reciprocal of fractions, is pretty easy because we're going to be multiplying the numerators and multiplying the denominators. But when we add fractions, we need to have the same common denominator. And to do that, we need to find the common denominator between this fraction here and this fraction. If I were to rewrite 3x plus 8 cubed, I could also write it as, so this is 3x plus 8 cubed, I could write it as 3x plus 8 times 3x plus 8 times 3x plus 8. And this would be equivalent. We also have a 3x plus 8 squared here. So 3x plus 8 squared could also be written as 3x plus 8 and times 3x plus 8. So what we see is the denominator on this side, on this expression here, all it's missing to be common to the other one is a 3x plus 8. But we can't just put that 3x plus 8 there. What we need to do is, if we're going to do something to the denominator, we have to do something to the numerator as well. It's got to be the same. So we can write x plus 10 divided by 3x plus 8 cubed. And then what we're going to do is we're going to multiply this term here by 3x plus 8. So that's going to give us in the denominator 3x plus 8 cubed, but we have to do it to the numerator as well. So if we're going to multiply the denominator by 3x plus 8, we need to multiply the numerator by 3x plus 8. So in the numerator we're going to get x times 3x plus 8. Now, since these are the similar denominators, they're the same, we can put them over one, just have them as one fraction. So we can write x plus 10, and then what I'm going to do is I'm going to expand this out. So I'm going to expand this part of it out. So I'm going to say plus x times 3x, which is 3x squared, plus 8x. And that's all going to be over this 3x plus 8 cubed term. And now, if we were to, I guess, collect like terms, we're going to have, and I'm going to put this 3x to the front of the expression. So 3x squared plus, let's collect like terms. So we have an 8x here and an x over here. So 8x plus x is going to give us 9x. And then finally we just have plus 10. So that is going to be all over 3x plus 8 cubed. And now we can look at the numerator and see if we can factor it. So if we look at the numerator, this is a trinomial where a, which is this 3 right here, does not equal 1. So the first step in any trinomial is to say, okay, well 3, the a term multiplied by the c term, so this a is 3 and the c term is 10, and that's going to be 30. Let's list all the factors of 30 to see if their sums equal this 9x. So if we do 1 and 30, there's 2 and 15, there's 3 and 10, what else? There's 5 and 6. So if we look at all these factors of 30, we realize since everything's positive here, right, there's this positive 9x and this positive 10, these factors are all going to be positive as well. So if we look at all this, it's going to be 1 plus 30, that's 31, 2 plus 15, well that's 17, 3 plus 10 is 13, and 5 plus 6 is 11. So none of those factors actually added up to this 9x, which is what we're looking for. So what we can say now is this trinomial here doesn't have a factor that's going to be a whole number. So we're going to have to divide this up, and it's not going to be, it's not going to be very pretty. So what we can say now is this 3x squared plus 9x plus 10 divided by 3x plus 8 cubed, this is our final answer. And that's the simplified form of the above expression. So now we're going to go into the final question. So the final question is, we're going to have 3 over x plus 1 over x plus 4 over x squared plus 11x plus 10. So this definitely looks a little odd and different form than we've seen before. But what we need to note is that 3 over x plus 1, what we're really saying is 3 divided by x plus 1. If I were to write even like 1 over 2, that's really just 1 divided by 2. So what we can do is we can look at all of these, lines here, like this one, and this one, and represent them as division symbols. So I'm going to rewrite this expression and say 3 over x plus 1 divided by, so I just took this line here, this I'll do in blue, this line right here, and just represented it as this division symbol. And then I'm going to write x plus 4 divided by, or over x squared plus 11x plus 10. So now this looks a lot more similar to the forms we're used to. And if we're dividing by a fraction, we're going to be multiplying by the reciprocal. So we can do times, and I'm just going to switch these numbers, or these terms. It's going to be on top is x squared plus 11x plus 10 divided by x plus 4. So now we can look at each of these terms and factor the numerators and factor the denominators. So this term here really can't be factored any more simply. So we can just write 3x plus 1. And then this term over here, this numerator term, can be factored. So we can write, so it's going to be times x, let's see, plus something times x plus something. So what are the factors of 10 that are going to sum to 11? And that's going to be 10 and 1. 10 plus 1 is 11. 10 times 1 is 10. So that's going to be over x plus 4. And now we can see that this x plus 1 on this term can cancel with this x plus 1 on that side. So now we can write our final expression as 3x plus 10 divided by x plus 4. And that would be the simplified expression of our algebraic expression there. So I hope you guys got some value out of this video. If you did, please consider liking and subscribing to the channel. I'd really appreciate it. And let me know in the comments below what you guys want me to cover next.